You're like rebuilding all of those parts that they put in their TypeScript library. That's a big ask. You mentioned that one part of that has been particularly hard. Can you talk more about that?
Yeah. I mean, I like a challenge, and I've done all this while doing 2 consulting engagements on the side and all the other things that have happened, and like got married, like got arrested for protesting, still made this all work. PDS was like 100,000 lines of code at this point. So again, large amount of contributions to making that work. And it's still like, there's still some kinks to work out. I think that also kind of like shows that it's not impossible. And like, for me, it's engaging. I've seen people throw a couple little shots at like how I've written the code first time open source. I never really wrote code in Rust before, but I just like the Rust programming language. So I used it as the opportunity of like, I'll just do both. I'll learn app protocol, build app protocol, learn Rust, build it, and been having a good time doing that. But yeah, the PDS is complicated. The PDS is the personal data server. It is analogous to an instance in ActivityPub for folks that are familiar, but it is different. So once upon a time, the easiest way to explain it is like once upon a time, like the PDS was kind of the core backend component. Like people talk about the relay now and how that's centralized and stuff. The PDS it was at one point the app was just the PDS and a front end client, and everyone was on one PDS. Then they added a bunch of different abstractions like layers in between that, and then they added the relay and stuff. But at its core piece, like the PDS is the backend server, so it hosts your account, your password. It hosts this like important piece called it's your repository, and it's like a GitHub repository, but it has this like fairly complex data structure. I'm again, like I mentioned, like a more of a hacky, like not like a staff engineer or like senior engineer by any means. And so I never really worked with tree like data structures before. And I hate recursion from the bottom of my heart. But yeah, so the Merkle search tree has like both of those, but it's this like computer science concept that they like took from a white paper and implemented, that it's supposed to be able to kind of maintain its like speed and be able to be consistently updated with like for a pretty like large amount of data essentially. And within that, like there's already those components, and then it uses CBOR to do like its encoding. So there's pointers in the tree that are like CBOR encodings of the data. So it's like, I think I'm explaining that right. So there's already taking this like theoretical concept, they've implemented it in TypeScript, translating that over to Rust. There's all the different libraries that don't really come across well. Someone explained to me like there's like a bunch of different CBOR libraries in Rust, but like they're all kind of old. And so that there's just trickiness with that. What else was challenging? The sequencer. So, these are like the sequencer plus the WebSocket stream. So you're also doing like WebSockets, which is like basically like the relay is the word is like slurping, but it's like it's consuming from your PDS. So when your PDS comes online, you turn on server, create an account, make a post. Internally, there's a sequencer that's listening for the events that are added to the database, and then it creates like a queue of those events. And then for anyone listening, it's going to like output those events based on the cursor that they provide. And there's like a window of how many, like if you allow like events from 72 hours ago, et cetera. But you as a consumer, you could run your Firehose consumer straight from a PDS, right? The relay is like a convenience. So the relay is listening to all the PDSs on the network, essentially. But if you wanted, you could just consume from one PDS. And so the relay is just another consumer, essentially, but in mass. And so that was a tricky thing. I ran into all these deadlock problems, and there's just like new programming issues that I hadn't encountered before. Dealing with WebSockets, never used those before. There was just like efficiency, like even though I felt like I translated the code fairly decently over to Rust, it just didn't run the same for whatever reason. And so then trying to like identify and troubleshoot those problems. Then there's the protocol piece. So that's like something where the tooling that I'd like to build out. I think on ActivityPub and Mastodon, if you like want to build ActivityPub implementation, I think that's like a good way of describing that. You could build, there's like test suites that can say like, this is compliant with ActivityPub. There are no test suites for app protocol as of yet. So it was a lot of trial and error, seeing like, can I get the relay? Can I get the did server to accept a signed did document? Did I sign the document correctly with the keys? Then like getting the relay to accept my messages, and like the relay is not like outputting like really great error messages or anything like that. So then I had to run the relay locally on my machine and like add deep like a bunch of print statements. But this is the way I did it. I added a bunch of print statements to see like what is coming through on its end and like why why is it, what's its internal errors of why it's rejecting stuff. And I spent the most time I've ever spent looking at raw bytes and being like, oh, it didn't accept, the did PLC server did not accept my signed did document because the way SerDes serialized that it didn't handle the nesting of it correctly. And I had to serialize it as a string and then serialize it to JSON in order and add a respect sort order like to the like crate as a feature. And that got the correct order of bytes. Cause I looked at it and I was like, what it's supposed, and then I had like the core Blue Sky thing running, doing the same events. And then I looked at the bytes from both of them and they're the same numbers. They're just slightly like 5 of them are the wrong order. And like that was because of like the sort order. And so that was like one of those things where it's like, it took me really long to figure out. And I don't know that there was an obvious tool to do that. I've like started to find little tools that help with some things like that, where like CBOR, it's like you do this encoding, but it has like this tagged. So it has like, it starts with like the number 42. And I just found that like sometimes when you view the CBOR or when you view like a pointer, basically there's different ways to represent it. You could represent it as the byte, but like it's usually represented as the string format of it. And so like a hex string. And so like just choosing which of those you're actually passing and how you're supposed to interpret those, that was like, again, another hard problem to like figure out, because there's not something that's just telling you, hey, this specific field that came through, like this is wrong. And that's why you're getting these errors. Yeah. And then there's some things that just aren't clear. Like, you know, with the Merkle search tree implementation, like does the pointer, there's like a field called outdated pointer. So one would expect that if you change the underlying data, it's okay that the pointer is outdated at a certain point. But when I tried to do their test scripts and I did my test scripts, I was finding that like it wasn't the expected result. And then I had to like force the pointer to update in certain pieces. And I'm like, I don't know if I did something wrong elsewhere and now I'm like compensating for the first error, or if I'm, you know, or there's something else going on. So a lot of like non-obvious, and like being probably one of the only, at least at the time, was like the only person who was trying to build like a full PDS implementation and not just like pieces and components of it. It was a rough and lonely road. I spent a lot of time, like I would hit up the Blue Sky devs themselves, which kind of plays back into like people saying like, oh, it's centralized, but it's like, oh no, they designed it and we're trying to figure out, make it decentralized, but that means like I need to go back. So I'm like, hey, like, why am I encountering this? Or like, yeah. And like sometimes I thought things were a problem and they weren't a problem. And it's like, then there was stuff that's specific to their implementation. So all of these things, that was what made it tricky. New technology, new libraries, me being to certain concepts, like fundamental programming problems. And then like you're trying to build in an ecosystem that's a protocol. So like you need things to be compliant with the protocol and there's no like compliance testing. So you just have to like try, at least for me, it was like learning things the hard way.
Yeah, that sounds like a lot. You've bitten off a big chunk of complexity, and props for using Rust to do it. Like Rust is not an easy language to just build anything in to begin with, but doing this and figuring out the PDS and like, you know, working on the protocol and like trying to get all that to work, that's fantastic. And the community will be better for it, which is also one of the things that I'm excited about by Blue Sky in general. It's like these efforts hopefully will like build. So the work you're doing here is going to help someone else, and hopefully it like all comes back together.